USA shocks the world with new 6th-generation fighter jet tests. Hello everyone, and welcome back to the channel. Today, we're diving deep into one of the most groundbreaking and jaw-dropping developments in modern military aviation, America's brand new 6th-generation fighter jet. The kind of machine that doesn't just rewrite the rules of air combat, it deletes the old book entirely. For decades, the United States has been at the cutting edge of aerial supremacy, but what's happening right now behind those heavily guarded hangars and test ranges is on a whole new level. This isn't evolution, it's revolution. The story starts in the Nevada desert, where the dust never settles and the sound of jet engines echoes across the endless sand. Somewhere out there, in the restricted airspace above Edwards and Groom Lake, a silhouette moves faster, higher, and quieter than anything ever seen before. It's not an F-22. It's not an F-35. It's something entirely new. Test pilots describe it as a ghost in the sky, invisible, intelligent, and untouchable. This jet belongs to the Next Generation Air Dominance Program, NGAD for short, a project so secretive that even within the Pentagon, only a handful of people truly know what's going on. What we do know is this: in 2025, the first manned prototype has already flown. Not a mock-up, not a computer model, an actual, full-scale aircraft, built and tested in total secrecy. The United States has leapt ahead again, and the rest of the world is scrambling to understand how. The NGAD jet isn't just faster or stealthier, it's smarter. Its airframe blends the agility of a fighter with the endurance of a bomber. The cockpit, if there even is one, is fully digital, capable of being flown by a pilot or remotely, depending on the mission. It carries weapons you can't see, guided by sensors you can't jam, controlled by an artificial intelligence that thinks faster than any human brain. The heart of this machine is its propulsion system, a new adaptive cycle engine developed by Pratt and Whitney and General Electric. Unlike traditional engines that balance power and efficiency, this one can shift modes mid-flight. Need stealth, it minimizes heat and radar signature. Need speed, it unleashes an afterburner that propels the jet beyond Mach 2, maybe even Mach 3. It's the first fighter engine in history designed to adapt to the environment and the mission instantly. But the real shock comes from how it was built. In the old days, it took decades to develop a new jet. The F-22 took 15 years from concept to service. The F-35 took nearly 20. The NGAD prototype was built in just 1 year. How? Digital engineering. The same technology used to design Formula One cars and space rockets was brought into the military world. Engineers created a perfect 3D twin of the aircraft, simulated every bolt, every airflow, every line of code, and built it entirely in virtual reality before a single piece of metal was cut. That digital approach means the US can now build and test entirely new aircraft faster than ever before, an assembly line of innovation. And this new jet isn't flying alone. It's part of a family, an ecosystem of unmanned drones called Collaborative Combat Aircraft, or CCA. Imagine a swarm of loyal wingmen, small, stealthy, AI-driven drones that fly alongside the manned jet, each one capable of attacking, jamming, or scouting independently. Together, they form a digital wolf pack that can overwhelm any enemy formation. The pilot doesn't command them, he collaborates with them. It's man and machine in perfect coordination. Inside the aircraft, the pilot's world looks like something from science fiction. Instead of analog dials or even touch screens, everything is projected directly onto a visor or augmented reality helmet. The system reads eye movement, monitors biometrics, and predicts what the pilot is about to do before he even does it. There's no traditional stick or throttle, only gesture controls and neural interfaces under development by DARPA. The jet is more than a machine, it's an extension of the human nervous system. Its weapons are equally advanced. Laser pods are being tested that can burn incoming missiles out of the sky. Hypersonic missiles sit hidden inside internal bays, capable of hitting targets thousands of miles away in minutes. Electronic warfare systems can blind enemy radar, shut down satellites, and confuse entire networks without a single shot fired. In short, it's a flying supercomputer with wings. But the most unsettling part: nobody outside America knows how far this technology really goes. Satellite images show strange contrails and mysterious aircraft at high altitude. Rumors suggest there may already be 2 or 3 different NGAD variants, one optimized for air dominance, another for strike missions, and possibly a naval version for aircraft carriers. The Navy's version, sometimes called FAXX, could replace the F/A-18 Super Hornet and operate seamlessly with unmanned combat drones over the Pacific. That's what's truly at stake here: the Pacific theater. As China pushes forward with its J-20 and the upcoming J-31 stealth fighters, the balance of power is shifting. But with the 6th generation jet, the US intends to make sure the sky stays American. And not just for today, for decades to come. Now let's step back and understand what makes the 6th generation fighter concept so radical. Each generation of fighter jets brought something new. First generation, straight wings and subsonic speed. Second, swept wings and early radar. Third, supersonic flight and missiles. Fourth, agility and multi-role capability. Fifth, stealth and network sensors. And now, the 6th generation, where AI, autonomy, data fusion, and adaptability converge. It's no longer about who flies faster, it's about who thinks faster. To maintain that edge, the U.S. Air Force partnered with Boeing, Lockheed Martin, and Northrop Grumman in a race unlike any before. Each company submitted digital prototypes. The Air Force secretly selected one design for full-scale construction. That aircraft has already flown, and though photos are classified, insiders describe it as having diamond-shaped wings, blended fuselage, and almost no visible inlets. Some reports say it's larger than an F-22, yet lighter thanks to new composite materials. There's also speculation about new radar-absorbing coatings. Unlike the black or gray paints of older stealth aircraft, this one uses metamaterials, engineered surfaces that manipulate electromagnetic waves instead of merely absorbing them. That means it can literally redirect radar beams away from the receiver. Combined with advanced infrared suppression and active electronic camouflage, the NGAD jet might be the first truly invisible aircraft to all sensors: radar, infrared, even acoustic. Powering all of that is data. The 6th generation fighter is built around information dominance. It connects to satellites, ground sensors, ships, and other aircraft in real time through a classified network known as Joint All-Domain Command and Control (JADC2). This allows every American asset, from submarines to drones to space systems, to share data instantly. It's like turning the entire battlefield into one living organism, where the fighter jet acts as the brain. When you imagine that level of connectivity, you start to realize why this is such a game changer. A Chinese J-20 or Russian Su-57 may look stealthy, but they're not part of an ecosystem like this. They fight as individuals. The NGAD jet fights as part of a swarm, a neural network in the sky. Even the way it's maintained is futuristic. Built-in sensors constantly scan every component for wear, predicting failures before they happen. AI maintenance algorithms automatically schedule repairs, order parts, and update software mid-mission. The result: zero downtime. The Air Force calls it predictive sustainment, and it could save billions of dollars annually. Speaking of cost, Early estimates suggest each NGAD fighter could cost between $250 million to $350 million, making it the most expensive fighter ever built. But the Air Force argues it's not a replacement for mass numbers, it's a replacement for risk. One NGAD could control a dozen autonomous drones, perform electronic warfare, and execute deep strike missions without refueling. It's not just a fighter, it's a force multiplier. Now let us talk about its role in future warfare. In the next decade, wars won't be fought the same way. The battlefield will extend into space, cyberspace, and electromagnetic domains. Stealth, speed, and firepower will matter less than the ability to dominate data and decision-making. The NGAD jet was built for that world. It can identify targets long before it's seen, decide the best course of action autonomously, and execute missions even when communications are jammed. That's not science fiction, that's already being tested. One of the most astonishing breakthroughs lies in its AI co-pilot, nicknamed Skyborg. This isn't just autopilot, it's a sentient assistant that can handle flight, tactics, and even combat decisions. The human pilot becomes more of a mission commander, overseeing multiple assets at once. In future conflicts, one pilot could lead an entire formation of unmanned aircraft, each powered by AI, each capable of acting independently yet in coordination. It's like an orchestra where the human sets the tempo and the machines play the instruments. All of this has massive implications for global power. America's rivals are already reacting. China has accelerated its own 6th-generation project, rumored to be testing under the codename JX. Russia's MiG-41, still in development, aims to reach hypersonic speeds, but analysts doubt it will match America's production capability. Europe is pushing forward with its own programs, the Tempest in the UK and FCAS in F.